Hey team, it's John. You are on the JRB Tree Climbing channel. JRBtreeclimbing.com is my website. This is also the name of my Patreon, should you wish to support me in my journey with safe climbing innovations. About a year ago, I introduced you to the JRB Ascender Hitch, and we're going to have a dedicated knot tying video today to show you my preferred tying variant, and that is the 5-2-3 tied in soft bridge mode. Here on the left we have 7mm cord tied on 10mm rope. On the right we have 6mm cord on 8mm rope. These two hitches are tied in the opposite chirality. I consider this one a left-handed ascender, and I consider this one a right-handed ascender, and that I have a carabiner fashioned into the friction hitch to serve as a handle. Hence the name ascender hitch. If you're familiar with the mechanical hand ascender, this carabiner allows the hitch to operate in much the same way. That's the first key novel feature. Another key novel feature is the ability to transform the hitch to run it in what we call soft bridge mode, where it's got two loops at the bottom instead of one loop at the bottom. And that feature, it allows, I'm going to remove the handle, it allows this unique one-handed tending operation when it's in this configuration. And it is transformable by shortening that loop. It's transformable into a single loop variant that you see on the other side. So these two hitches are tied exactly the same, just in the opposite chirality, but we can undergo this transformation where it goes from soft bridge mode on 2 loops, load on 1 loop, we can self-tend, and we can add the handle. Another really important feature of this friction hitch, crucially important for climbing applications, is that it is relatively easy to break under load. If I put my full body weight on this loop here, unlike a Prusik or a Diestel or just about every other friction hitch I'm aware of, I am able to then break this friction hitch with just one hand to transition into rappel. And in climbing applications and in failure recovery applications, for example, a climber where their platform or stick broke and they need to, they're on a friction hitch, they need to get down. We need to break your friction hitch. And this one enables that. That's for me, at my body weight on these materials. You'll need to test your own ability to do so. But a very important feature is its breakability under load. The friction hitch is tunable in the sense that we can add coils. I said a 5-2-3, whereby the 5 refers to the number of coils on this upper stage. We can tune it if a particular combination of cord and rope didn't warrant 5, particularly thick cord and thick rope, we can take that down to a 4. And in particularly wet conditions or thinner cord and thinner ropes, there have been instances where I needed to go to 6. So we'll leave that as a detail and show you how to tie the hitch. I will note that there is one other variant we're going to leave on the table. I'll bring that up. There's a dedicated video on this. This is what we call the non-jamming variant. As the name would imply, it is less prone to jamming than any other variant. And I was asked just yesterday by a gentleman in my group, Josh, when I would use the non-jamming variant over the regular variant. Well, the first point is running it in soft bridge mode does decrease its jamming properties. So this is this variant, the soft bridge mode variant that you're seeing here, is more jam resistant than the original 5-2-3. So I would only use, for me, I would only use this non-jamming variant where I needed it like this, ultra compact, just ultra compact, as small as I could possibly use it, or where I needed to tend it with my hands. So I need both of those features when I execute JRB hitch climbing. So you'll be seeing this variant in JRB hitch climbing. But for the JRB climbing system, this is what I recommend and what I use. To build an SRT system, this is what I recommend and this is what I use. Okay, let's get started and let's tie both of those, the left and the right-handed variant. Now, we're not going to go real deep on length specifications today because we've got jrbtreeclimbing.com where I am storing an increasing treasure trove of length information. On the length specifications page, you will know if you start for a given cord and rope combination with a given length, this is the working end I would start with, and this is the size of the loop that would be produced. So I have here just measured out, I have 6 feet or 72 inches or 183 centimeters of 7mm cord. And on the right, I have a 42 inch or 107 centimeter working end one. So this is the working end, and I'm going to get started in tying the ascender. I will start with 2 coils in an upward fashion in the Z chirality and then drape that down across the original standing end. Take it around the back, and now I'm going to be taking that and passing it down through these 2 coils. So I'm going to take this nail as a visual aid, insert it up between the rope and the 2 strands. That path I will be following down with the working end. So let's take that, let's put that down through and out the back. Goes out the back. And let's get that a little bit snug so it stays in place and take a close look at it. 2 horizontal strands bound by 2 vertical bars. The standing end remains where it started on the left side, and the working end is in the back. We take the working end, and remembering that coils went from left to right, we're going to make 5 more of them. 5 more of them up the rope. 1, 2, 3, 4, 5. Now, if you're tying along at home, I'll give you these opportunities to pause the video or to take screenshots, but I won't slow down too much and just try to keep going at a fairly reasonable pace. I then take the working end and I will be inserting it up through those first 2 coils. Where I started the upper helix or the upper stage, I created 5 coils. Well, the first 2, I will go under them with my working end. Okay. And then the working end follows this link segment. At this juncture, you can probably see that there's only one piece of cord connecting the upper and the bottom stages. That's that link segment here on the left. I'll be following that down, and now the working end goes under this strand and then under that strand. See how that works. Back through the bottom stage. So this here, it's not dressed yet, but that represents the original 523 JRB ascender. 523 meaning 5 complete turns on the top, then up through 2, and visible on the bottom are 3 horizontal bars. That's the 523 JRB ascender. Now, before I transform this into soft bridge mode, it's really important that we understand how this friction hitch is tuned and how we get it to hold, how it jams, or how we get it set just properly. So this working end here that passes through the bottom stage, let's get a little slack up into the top. And let's see what happens now. This friction hitch doesn't hold. It's not holding. It's got too much slack in the top. And we get that slack out by pulling on that descending strand. Now it's holding. Okay, so you get the idea. We need to get that tuned properly, and if we need to retune it, it's that simple. Now, let's transform it into soft bridge mode. So again, the working end is here on the right, the standing end is on the left. Well, the standing end is needed to complete this, so it's not a standing end anymore, it's the new working end. We are going to insert that. Let's get in real tight here. We're going to insert that at this location on the same side. It's a left-handed ascender. I'm working on the left side where the link segment is on the left. I am going to choose this location above these bottom two strands. I'm going to insert that nail at a slightly downward angle. And in that location, that's where I'm going to insert the original standing end from the left side. So let's take that. You probably see that little bit of light there. Let's utilize that gap, and so now I've formed one of my two loops. And now, and this is prerequisite knowledge, but we're going to tie a hunter's bend on the right side to connect these two strands. So please refer to my earlier video on tying the hunter's bend, which I'm doing right now in real time. And that is my preferred bend for closing this hitch. Now you can use a different secure bend than the hunter's bend, but again, it's my preference. It's fairly easy to tie. It's fairly compact. It's very strong, and I can always untie it under the load of a normal climbing application. If you put tons on it, then it might require some special effort to get it removed, but that's not the case in a climbing application. So here I have the JRB Ascender in soft bridge mode, ready to go. Let's see where I would put my handle. So if I'm running it in soft bridge mode, I probably wouldn't use a handle. It's working great. If I put a handle in, it would be, I always lengthen the loop. The single loop is the one with the bend. If I accidentally or just make an attempt to make the other side the loop, well, that doesn't work. The bend acts as a stopper knot. So the side with the bend is always used for the longer loop. Before we put our carabiner in, let's get it a little too loose again. Let's see what happens if it's too loose. It doesn't hold. Doesn't hold. Let's trim that out. Let's just pull in the bend, and now it's holding. That's simple. Okay, now let's put a handle in. When we put the handle in this location, and I have climbers doing this in different locations, but this is my preferred location for the insertion of the handle, and that is, it's there. It's the bottom, just grabs that bottom drop bite, and it will encompass. Now, because the carabiner just kind of works best in my hand this way rather than this way, I bring it in from the back and I capture both the rope and the cord. That's where I like it. And you can use different kinds of beaners for this. And they don't necessarily, for example, this is a climb rated beaner. I love this beaner for a munter, but for this application, it's just too big. I mean, it works, but I prefer something smaller. And because it's only being used as a handle, well, this is a cheap 12 kilonewton beaner. I would never trust my life on it from a questionable manufacturer, but it's really nice and small, and so I can get it on there. It's a little tight, but I've got myself a handle. Now, this is a lot to tie, and I understand that, but this isn't a friction hitch that we tie necessarily every time that we climb, right? So this is used more in tether and lineman's belt and climbing system applications. Okay, let's transfer our attention over to the right, where now I will be building a right-handed JRB ascender. And for this, I will be using, excuse my interruption of your view, but I was referring to my overhead yardstick where I could take this 5 feet of cord and get a 3-foot working end, and I'll be operating from right to left. It's a little bit harder for me not to obstruct your view, but I will do my best. And everything's the same, just in the opposite chirality. I go around once, I go around twice. I drop that line down, and then, and I'll do this without the nail, I'm going to go down through these 2 strands. And out the back. Take a look at that. That's the bottom stage. I then take that working end that shot out the back, and remembering that I started from right to left, I will make 5 coils in an upward fashion. 1, 2, 3, 4, 5. I then will put it up through the first 2 coils. 1, 2, and out the back. So you've got a little slack in there. Might as well take it out now. There's no sense taking it out later when we can take it out as we tie it. And now I'll bring that working end back down and work it through the 2 bars on the bottom stage. There's the first one, and there's the second one. I usually like that running through the middle. And that seems to be taking load immediately. Seems well dressed. Okay, again, the original standing end is on the right side. And I am now going to insert that on the right side in this location over the first 2 horizontal segments on the bottom stage. That location, I'll be inserting the original standing end. There we go. And now I will simply create my hunter's bend to finish the application. Again, please refer to the earlier video on tying the hunter's bend. The hunter's bend is really just the marriage of 2 overhand knots. And being well versed in tying it, I'm pretty confident I got that right. I generally would take a little bit more time to make my tails symmetrical, but trying to keep my elbows out of your field of view. So I can tell with some experience that's got a little bit more slop than I would want. I would want to dress a little bit of slack out of that. Let me hammer on that a little bit, and you can see some slack emerging in the hitch. And how do we remove slack? We locate the side with the bend and simply pull some of that slack out. I can take it from being too loose to too tight. Let's test it out in soft bridge mode. Let's test its ability to move. I generally pull the rope backwards and the cords frontwards. Great. Feels fantastic. And lastly, I will insert the handle one more time. Let's come in closely to see where the handle goes. So again, this is a right-handed ascender, and so I'm going to grab the cord and the bottom strand on the left side. So that's the location of the ascender. And I'm using, again, a cheap 12 kilonewton carabiner, but it's really just a handle. I bring it in from back to front, and it nicely accommodates my hand. And so let's take a look at the finished product here. Pardon my inability to self-film and zoom and talk, but that's it. We've got a mismatched pair, but we've got them on different diameters. Here a left-handed and here a right-handed JRB ascender 523 in soft bridge mode, and this is my preferred variant, especially for my JRB climbing applications. Thank you very much.